All right, so we're going to talk a little bit about parallelograms, just kind of a quick and dirty for you guys that are on the road. So to the right we have a parallelogram. A parallelogram is a quadrilateral whose opposite sides are parallel. Squares, rectangles, rhombuses are all parallelograms. So all these properties we're going to discover apply to all those things. So in class I asked them to kind of look at the different parts of this picture, and then I kind of went over GeoGebra, and we noticed that what sides are congruent. You can see that opposite sides are congruent, right? And that these are congruent, meaning that the diagonals bisect each other. So the bisected diagonals are congruent as far as lengths. Okay. Angles that are congruent are, you can see the opposite sides are congruent, opposite angles are congruent. And then we also know that these are congruent because of alternate interior angles and alternate interior angles here, but that's kind of a part of this. Are congruent as well. So once again, all supplementary angles, or all consecutive angles, are congruent. And it's not like a trapezoid where these two, so these are consecutive angles, right? And these are consecutive, and these are consecutive, and these are consecutive, and all of them are supplementary. And like I said before, diagonals bisect each other. But these angles are not necessarily bisected, and there are no right angles, right? So these are not perpendicular. They intersect at various different angles. So to review, parallelogram consecutive angles are supplementary. The opposite sides are congruent, and the diagonals bisect each other. Those are the big ideas. Now, here's a couple examples, right? So because we know these are parallel, we know this is a parallelogram. And we know that opposite sides are congruent. So we know that this is 15, 15, 26, 26, because those are congruent. So then we're going to add all those up together. That's 52 plus 30. So the perimeter will equal 82. Now this one, so AO, we know that this is 11, and BO is 7. So then we know that AC, because we know that this diagonal bisects this, so this is going to be twice as long, so AC is 22, and BD, this is going to be 7 also, so this is 14. Now moving on to here, we have a perimeter equals 46, right? So we know this is 2x minus 7 because these two are congruent, and we know this is x plus 9. So then we can set up an equation and say 2 times 2x minus 7 plus 2 times x plus 9 is going to equal 46. So now we're just dealing with algebra. Distribute that in. 4x minus 14 plus 2x plus 18 equals 46. And then we get 6x plus 4 equals 46. 6x equals 42. X equals 7. So if x equals 7, now what they asked for is AB. What does AB and BC equal? Well, AB is here, so I'm going to plug my answer in here and say 7 plus 9, and that's going to give me, so x plus 9 is AB, and so 7 plus 9 is going to equal 16. So AB is 16, and BC is 2x, 2 times 7 minus 7, and so 2 times 7 is 14 minus 7 equals 7. So BC equals 7. So those are using those properties to prove different parts of triangles, and that should kind of get you through the rest of this. I'll have a key up if you have any more questions. Anyway, I hope the competitions go well, and I'll talk to you later.